Hey guys, how are you doing? Today I'm going to show you how to do linear regression using SAS. So before that, I want to quickly talk about what is regression. Regression is a very powerful statistical method or a statistical tool which is used to find out the relationship between two variables. Obviously, one of them will be dependent variable and one of them will be independent. For example, dependent variable can be weight and independent variable can be height, and also dependent variable can be water consumption and independent variable can be population. And regression is used to predict dependent variable using independent variable. What we will do in regression is we will make a formula. We will establish a formula using regression, also called regression equation, and in that regression equation, dependent variable will be the function of independent variable. For example, something like this. Let me write. So this is dependent variable and it will be a function of independent variable, something like this: m x plus c. So this x is our independent variable and this y is our independent variable. For example, this y can be our height and x can be our weight, or this y can be our water consumption and this x can be our population. So to make it more clear, what we can do with regression is, let's say the population of New York is 5 million and water consumption is 100,000 million per day. Then what is the population, what is the water consumption of New York if its population is 10 million? So we can exactly use this formula if we know what is the value of m and what is the value of c. And with the regression, we will know what is the value of m and what is the value of c. Isn't it interesting? Regression is also used by meteorological department to predict weather. Obviously there will be so many other variables. Now we are only talking about one variable, one independent variable, but there can be many independent variable. It can also be used by business to predict sales. It can be used by electricity company to predict electricity consumption, and it can do many more things. So it's always useful if you know regression. So I'll give you a brief example again. So let's let's have a closer look. So this is a x variable and this is a y variable, and this is a population of any city, and this is a water consumption, and this is 0, and this is 10,000, 20,000, 30,000, something like that. So for example, when population is 10,000, water consumption is somewhere over here. So when population is 15,000, water consumption is somewhere over here. And when population is 20,000, water consumption is somewhere over here. When population is 30,000, water consumption is somewhere over here. So you can see here, guys, it looks like there is some kind of relationship. As population is increasing, water consumption is also increasing, and if we try to make a straight line here, it will be something like this. This is called a regression equation. So if we extrapolate this line to here, we can probably see what is the water consumption for this population, which is, let's say, 50,000. So we can predict the water consumption of 50,000 population using only this information, or even population of water consumption of population of 100,000, where the line will go something like this, or even this side. If we can do regression from this information, and if we can establish equation, regression equation, something like this: y equals to m x plus c. So this c here is this part, which is called intercept, and this yum is the coefficient of x, which we will find out after I show you how to do regression. So let's see. So what we will do today is first we will conduct regression in Excel, just to give you an idea, and after we do regression in Excel, we will be able to establish a formula in the form of y equals to mx plus c, and we will predict dependent variable using regression equation. Then we will repeat the process in SAS. First we will do with proc procedure, and then we will also do with a proc glimmix procedure. I want to show you both of them because proc glimmix procedure deals better with the missing variable, whereas proc reg may be less powerful than proc glimmix procedure. So let's do the analysis, guys. So this is my data sheet. So what I want to do is I want to do a regression between expense and income. So income is our independent variable here, whereas expense is our dependent variable here, because as you know, expense will always depend on income. So higher the income, higher the expense, lower the income, lower the expense, and they are always linear as long as other variables remain constant. So right now we are only talking about this one variable, income, and we assume that the relationship is constant, and if one increase, other increase. We are not talking about any other variable because I don't want to confuse you now. So let's assume that there is a linear relationship. So let's establish a relation between expense and income. Let's do first using Excel. So we have total of 32 families, and one family has 21,000 in income and expense is $309. So let's do the analysis here. So to do regression in Excel, we'll go to data and then data analysis. So I want to do regression, so let's click OK. So our y variable, y is always a dependent variable, remember guys. So y is this, so drag from B2 to B33, and then our x is again from A2 to A33, and click label. You can we will have output in new worksheet, and we can have residuals and residual plots as well. So I'm not going to talk much about residuals now because it will be too long. So let's click OK. All right, so let's not talk about residual. So now we got our output. So the most important thing here is this part, guys. So it looks like this is less than 0. This is less than 0. To make it more clear, what I will do is so number it is much less than 0. So let's it is much less than 0. So that means there is a clear definitive relationship between income and expenses. If this p value was more than 0.05, then there wouldn't be relationship, but now it is much less than 0.05. that means there is more than 95% of chance that there is a very high relationship between income and expenses. And the other important thing here to look is this part. So this is our coefficient and this is our intercept. So for example, I was talking about the formula y equals to mx plus c. So our x is income, our y is expenses, and this yum is this, and this c, which is intercept, is this. So for example, so So if you want to predict, let's do some prediction. Income, expense. So let's copy this here, control C, control V. So this is our intercept, and this is our coefficient. This is our coefficient, control X, control V. So let's do some predictions. So for example, one family has, we know this, there are 32 families, and we know the income and these are the expenses. But there is one family which makes 100,000 per year, and we don't know what is the expense. Let's see another example. A family makes 150,000 per year, and we don't know the expense. And another family makes 200,000 per year, and we don't know the expense. So let's see how much they spend from that equation. Control C, so control V. So let's use this formula, guys. So y equals to mx plus c. This is our this is our m, and this is our c. So I'll make it more clear for you. This is our m, and this is our c. C is intercept and m is coefficient. Sorry, there is a symbol. So equals to this is expenses are y and income is our x. Y equals to mx plus c. So m is this into x plus c. So you can see, guys, so the income of family with income 100,000 is $1,070. Let's drag it down. So the income of family with 150,000 income, the expense of family with 150,000 income is 1,551. Similarly, the expense of family with income 200,000 is 233. So let's copy this, control C, and let's go to our original data set, paste it here. Yep. So now let's see, guys, so if this is making sense or not. So let's arrange it in sequence, sort smallest to largest. All right, so let's see, guys. So if you see the highest income from our original data set, which was 42,000, and that was spending 513. So it is almost double, the income is almost double, and this is also almost double. So that means it is making sense. And this is almost 4 times, and it is almost 4 times. So it is making sense. So we can easily predict. Remember I told you earlier, how can we predict using this data set and using regression. So you can use this regression for so many other things. You can use regression in your own real life example. So I already told you how to do regression in Excel, but let's do it in SAS, which was our main objective. So I'll show you how to do in SAS. So I have opened SAS here, and I'm using University Edition, guys, because the other version of SAS is quite expensive and University Edition is free. So this is our code window, this is our log window, and this is our result window. So let's start with the first, and I have already showed you my original data set. So I'll copy that data set later on. So data first, you can call it second also, it doesn't matter. So you have to type some of the codes. So this one is quite interesting with SAS University Edition, because whenever I used SAS University Edition, it asks me to put this, otherwise it doesn't read the data. So this is, you can exactly copy paste this part, guys. So input, input will be our dependent and independent variable. So first we put our independent variable, which is our income, and then second we put expense. I'll show you later on. So then you can just put cards. So let's copy our data set, guys. So this is our data set, so let's copy it. So we had 32 families, so let's copy it, Control C, and then paste exactly in SAS. Yep. So this is our on the left side is our independent variable, and on the right side is our dependent variable. So expense, this is expense, income, this is income. So let's have another semicolon here, and now let's start our actual analysis. So let's do regression procedure first, proc reg. So proc means procedure, reg means regression, and then model expense equals to income, and then you can do run. So model y equals to x, y means expense, x means income. So let's try to run this, guys. So click run. I think there is some error here, so sometimes if there is a small mistake in code, there will be an error. Let's wait for some time. Let's see what the error was. So it says no logical assign for file name data line. So I think it didn't matter too much because we already got the result. So you can see here, guys, so these are the pictures of residuals. So it looks like they look fine because they are evenly spread. So the most important part here is p-value. So p-value is less than 0.05, so that means they are dependent on each other. That means dependent variable is really dependent on independent variable. That means expense is really dependent on income. If the p-value was more than 0.05, then we would say there is no relationship between expense and income. But now, because it is less than 0.05, there is a definite relationship. And you can, another important part is this one. So where this is intercept, 102.41 is a intercept, and 0.00973 is a dependent variable. So let's copy this part. So I'll write it in my copy first. So 102.41660 is our intercept, and 0.00973 is our coefficient. So I'll go again to Excel. So previously our intercept was 105.44, but now our intercept is 102.41660, and our coefficient is 0.00973. So let's again predict the expense of family with 100,000. So Control C, Control C, Control V. So let's again Control C, Control V. Yep. So now look, there is a little bit of difference between between the calculation analysis done by SAS and analysis done by Excel. So in the real world in the real world data analysis, the scientist always prefer SAS because SAS handles missing value really well. If there are some missing values, Excel cannot handle that really well, because in Excel you have to either delete that data set, that particular point, and sometimes missing value can be really important because that value can affect the other values as well, and SAS handles that really well, and glimmix handles that even more in a better way than rec procedure. So let's do the same thing with glimmix. So I already showed you how to do in reg, so let's not spend more time in proc rec procedure. So let's do it in glimmix. So proc glimmix, then so class. So usually when we add class statement, we add our yux variable here, but if you don't add yux variable and just put semicolon, then it assumes that the SAS assumes that it is a regression, you are about to do regression. So let's do model. So y equals to x, expense equals to income. You wanna do solution, sorry, yes, so UTION solution. Oops, sorry again. And then if you wanna see residual, then you have to type a specific statement, output out equals to second, predicted equals to pred. This is just for residual. If you don't want to do that, that's fine, but it's always better to see residual. And then let's click run. So let's only do glimmix as we already did rec procedure. So sometimes it takes some time. So it looks like there are no errors. Yep, now we do glimmix. So this is a glimmix, and we are doing exactly same thing, guys. We first did with Excel, then with rec procedure in SAS, and then now with glimmix procedure. And it looks like with the rec procedure and glimmix procedure, we got exactly same result. So 102.42 is our intercept, and 0.0097 is our coefficient, 0.00972. So let's go to Excel again. So this is using reg, this is using glimmix. So with glimmix 102.42 and 0.00972. And again let's predict. So Control C, Control V. So let's, yeah, so there is a small little bit of difference. So if you want to know more about the difference between glimmix and rec procedure, so you should probably read more about the fixed variable, random variables, and how glimmix treats missing value, how SAS treats missing value. So the glimmix procedure is really nice because if you have some missing value, then you can still use that value. You can still use that data. That's why I always like to do analysis using glimmix, because sometimes if you don't have a dependent variable for that particular missing data, then if you don't have that particular missing data, then rather than deleting, it might still make a value, because that might affect your residuals, that might affect your randomness of your data set, because randomness of your data set is really important. So I hope guys this is more clear for you. So if you want to know more about missing value, what is the importance of missing value, how glimmix treats missing value, then, and how how glimmix or SAS is better than Excel, then you can inbox me, you can write down in comment, and then I will do more analysis to show why SAS is better than Excel, and why if you do analysis in Excel, it may not be accepted by journals, but if you do analysis in SAS, it will be accepted in journals. Alright guys, so thank you so much for watching my video, and I hope you like it, and please suggest if you want to see any more of my video. Thank you so much.